Alright everyone, welcome back again, and let's get started with our classes, shall we? So in the previous lesson, as you have seen before, we have created the contact class with their properties, of course, and the contacts constructor, which you have to nullify everything if you're making a default constructor, and it's really advisable and you have to do that. And the contact, the full actually constructor, we have everything. Alright, so this I can consider for the time being, I can consider that this class is complete, and I can actually move to the other classes. Alright, so let me collapse this little guy since I don't need it, and let me close this. So actually with a middle click I did that. Right click, add, probably this could be off screen a bit, this part of the recording, but here you go, add, and then you add a class. Alright, so we need to add a class where you can put your professional contact, let's say. Alright, and I'm just gonna hit add. Now of course you need to make it public so you can access it. Okay, now a very important here thing to note, as far as you saw here actually on the notepad, well, I mean this pretty primitive prerequisites of your application, you should have actually everything plus that, and you should have everything plus that for each class. Well, probably some of you who are not experienced in object-oriented programming will say, why not? I'm just gonna hope, like I'm gonna take out everyone and just put them down here plus that, and then you're gonna create another class and just take everyone and put it down there in the other class for the professional or for the personal contact, which of course it's completely wrong thing to do. So there is something which is called an inheritance. So you inherit from a class, you inherit all its properties, and all its properties, or I'm talking about all its class members and the functions also there. So in order to do that, and I believe I already explained inheritance in the previous lesson, so I believe we already understand each other here. I'm going to inherit from the contact class. Now this is how you actually inherit from any base class in C# or in C++, probably also the same thing. Probably you have actually public class, professional contact, the name of the class, and then you put the colon thing, and then you put the contact, which is the name of the class, and this is it, done. You don't need to put anything additional. I believe in Java it was like extends, actually this is the keyword. Alright, this is actually the same for classes and interfaces. Okay, this is a very important thing to say. Let's move forward. So in this professional class, I'm going to actually make a public property, which is going to be a string again. And since this professional contact, we agreed that we're going to have a company name on that one, isn't it? So a company name with a get and a set properties. Okay, so we can read and write. Now this is it. Now if I go to the professional contact, public professional contact, since this is going to be a constructor, we have actually to do a actually to call the base class first, the base class constructor, and add to it that part and nullify them all. Alright, so here's actually what's going to happen. Now in order actually to make a base class, to call actually the base class, in C#, you call actually this part is the base class, and this is the child class. Alright, this is how you actually can do it. You put a colon after the constructor name, and you type just base, and then of course you call whatever whatever constructors you have. So you can call this or this. I'm currently gonna call the default one. Okay, and I'm gonna go here and say this dot company name equals to null. So automatically I'm gonna have all the basics functionalities, or all the basic members of the my base class all of them are gonna be null by calling this little guy plus that one. Okay, now in I'm gonna actually keep it like the default one. I'm not gonna actually have the complete one for now, just to minimize the code and time. Probably later on I'm gonna put it in other lesson. Alright, just once we polish out everything, so it's gonna be just easier now just to write the whole thing really fast. So return now what I'm gonna return, actually the base dot to string plus, alright, plus since I already have a new line out there, the last one, so I can actually type immediately company name colon plus this dot company name. There you go. Now look into this code, you say, whoa, hold on, man, this is like, come on, you know, but it's quite logical. I mean, you are actually inheriting from the contact class, right? When you want to call to string, you would like to present everything from that professional contact, right? But the problem is professional contact has only this. So I have actually to show the contact, the whole thing with the nickname, with everything, plus this company name. So in order to show that, I will not actually like access everything and write that again. I just can say the base class dot to string, and as you see here, like when I said base dot, I have the access of all the members in that class, in my parent class. So I'm gonna just say to string, and then plus the whole thing. Okay, I believe this is quite logical. Now if I go again to the references business, here you go, add a new class. I'm gonna call it like personal contact. Here you go, personal contact. I believe as you see here, this is quite, how can I say, really basic, and there's nothing here. It's more like a mechanical work a bit, if you didn't notice. But in the address book class, we're gonna have really a lot of brain work there. Well, it's not that complicated to have a lot of brain work, but we're gonna have a lot of brain work there too. Alright, I'm gonna have almost the same thing. So if I go here, oops, sorry, personal contact over there, and of course I have to make sure it's public. Let's hope I will not forget anything there. And then public, I'm gonna keep it low for now. I'm not gonna use the date time class. I'm gonna just use the normal string for now, and then later on, why not just go for it in the forums and show me how can you use the date time class. And I believe it's really easy. Just when you hit the dot, you're gonna just see the functions and the descriptions, and then you can actually come up with a solution. I mean, this is a really cool idea. You just start researching. Alright, let me try here to say public personal contact, and then I'm gonna have a default constructor again. I'm gonna call the base one default one. Oops. Okay, and I'm gonna have this dot birth date is gonna equal to null. Did you notice this? Like email, family name, first name, nickname. I got everything plus the birth date. So this is really nice and neat way. By the way, if you hit Control Space, you get actually this. You know, when you hit the dot, if you lose it, just hit Control Space and you get it back again. Equals to null. I'm not actually gonna bother with creating a full constructor here. Just time consuming. Public override to string. And then I'm gonna just say base to string plus birth date, or how did I? Okay, so plus, and then I'm gonna have a this dot birth date. All right, I believe we are done here. So this is actually the basics. This is the basics of inheritance. Right now you have got how it looks like in C#. Okay, how to inherit from a class, you have it. How actually to call a constructor of a class in your constructor of the child class, here you go. How to override to string, to override a function, this is the basics of inheritance overriding, here you go, we got it there. So probably we almost covered, of course there are a lot of courses. I mean, huge courses over really large universities for taking semesters and semesters for just inheritance and polymorphism, but just I'm right now showing you just a bit of part which you're gonna be commonly using. Alright, so let me close this and close that, and we don't need that one too. Alright, so we have our contacts. I mean, this is the contact class, but the problem is we're gonna create objects. Now I can create objects in the memory, but how can I refer to them? How can I manage them? This is really a very good question, because if I create an address book, if I just keeping putting input just contacts and contacts and contacts, you just don't know how to access them later. At least okay, let's say I'm not gonna just dump them in the hard drive. Let's say I'm just gonna use them at least in the memory for the time being. We don't have really an idea how actually to manage this. Well, at least by these classes. So we have actually to create a data structure. A data structure is arrays, linked lists, hash tables, you have, name it. Just these are actually called data structures, where you can actually manage your applications or manage your objects in some certain memory management way. Let's say, for example, you are managing your object in some certain structure based on some certain algorithms. Okay, this is how the stuff works. So I will create inside my business an address book class, of course, but it's gonna be a class like any class, but we're gonna make it a bit different. So if I say address book class, okay, just for you to know, this is called address book app, not the address book. So I actually made this on purpose, so you're gonna have everything meaningful. Try to name your classes as meaningful as possible. Alright, just keep that in mind. So once you're gonna reuse them later on for any kind of solutions, it's gonna be easier for you to just reuse them. Okay, let's keep moving forward then. Here actually we have two options. We have a lot of data structures ahead, and we can use generics. Generic actually is actually like if you are using, let's say, a data structure, let's say an array or a list. For example, if I make a list of contacts, let's say, oops, sorry, that's my bad, contacts. Alright, and let's say I'm gonna call it the contact list equals to new contact. Now this is actually the new list, of course, of contacts. This right now is gonna ensure that whatever gets inside this list is gonna be only a type of a contact. And of course, since we have inheritance and polymorphisms gonna be on, then your personal contact and professional contact will get into there just nice and neat. If for people who really forgot how polymorphism work or what polymorphism is, polymorphism, if we are talking really scientifically, I mean low, and I mean not even a computer science level, a polymorphism is, for example, in the field of medicine, is like a crystal, which the same crystal which represented in some different ways. So you have the same circle, but crystal, excuse me. You have a same crystal, but it's represented or shown in a different ways. It is somehow it's the same polymorphism. It's like, let's say, for example, your father owns a company, for instance, and nobody allowed to get into his, for example, into the company, let's say, or into his, or into the company building, let's say. So once you go there, you're actually the child of your father. So imagine that the father is your base class and you are the child class. If you are trying to get into the building, everybody will just allow you because he's his father, you know. They're treating you almost the same. Alright, so this actually goes, here's the polymorphism goes. So it's like, I told you, it's more like, really, object-oriented programming is so similar to real life than we think. So this is, generics ensure here that all types of objects that you have, that you have flying around the memory, only the ones which are going to get inside this list is only the contact class. This is faster for the compiler, faster for the application, much more secure, and there is no gonna be and there's gonna be really a lot of less exceptions for having, for example, type mismatches and all those stuff. Alright, so this is really very good practice to using, always use generics. I actually would like to use hash table for that class because we have some couple prerequisites I would like to add. Only a single nickname should be there. If somebody tried to put another nickname inside my address book, which is the same nickname which I have in my address book previous I already input, the application should tell me I cannot actually add this contact, or I cannot add this nickname since this nickname already exists, so please just rename or change your nickname, or try to, you know, just try to input a different kind of data. So I would like really to use hash tables, but the problem is the hash table which I want to use, I have actually to use using system dot collections for that, but it's not actually generics. And if you it's not generic class, at least the hash table, there's a counterpart of hash table, which is called dictionary. We'll look at it in a moment. But as you see here, also Microsoft is trying to force us to use generics in our code because it's safer and faster, and it's really much more clean way of working. And you cannot really imagine how it is beautiful working with generics, especially in object-oriented programming and C#. The part where collection goes, this actually lists, as you see here, if you don't have this imported, at least until here, I mean if you don't have this generic part, you cannot actually use that list, okay? So this is a very important thing. This list is the equivalent of the array list, and it's, as you see here, it comes from system.collections.arraylist. There you go. This is the array list class, okay? So this is the, you can consider this is the counterpart of it. Hash table uses something which is called dictionary. Let me see, dictionary. And here the dictionary is a key and a value. Now a hash table, a definition of a hash table in books of algorithms is actually like a data structure of a key value pair. Now they are actually, a hash table is the family from the dictionary types of classes, because it's quite logical. You have a key and you have a value. It's like a dictionary. Like if you open English Bosnian or Bosnian English dictionary, you just open the book or open the dictionary and trying to search for a word, which is the key. So let's say you are searching for a meaning of a word. You are searching. This is the key. Searching by key, and the value is going to be the meaning of the word. So this is actually how it goes. The same thing, exact thing happens with hash tables, but of course you have something which is called a hashing function, using some hashing functions, using some hashing algorithms in order to map out or to store that, how can I say, to store actually your objects inside a hash table, and it's really very fast, extremely fast to search there. So this is one of the very nice features of a hash table. So you're gonna be really making applications that you're gonna be really proud of. Okay, so I'm gonna make a hash table. Oops, not hash set. Hash table. Okay, and I'm gonna call it my address book. Now, if you look here, let me say, just create a new address book. Okay. Oops, sorry, new hash table. My mistake. There you go. Now, if you see here, I just named it as a small letter and just kept it like B, capital B. All right. Now, there's something very important I want to actually to mention about how to know actually a notation of your application. We have actually in the world like 2 to 3 types of annotations in code styling generally. The standard which .NET uses actually like Camel Pascal notations, where there's of course Camel Pascal notation. You have a Hungarian notation also is used, and it's kind of people are actually, well, let me tell you one thing. Camel notation, let's say for instance, is according to, for example, to MSDN, this is Camel notation. Okay, if you are actually making a Pascal notation, the first letter is going to be capital and the next is going to be capital. And generally the second letter or the second word inside a notation, or inside if you are making, for example, say address book, you are not allowed at all to do this. address book like this. You have to make it B, so people differentiate the different words case. So they say this is a word and this is another word. Alright, this is the code signing we have to stick into. .NET uses usually Pascal / camel notations, this and this. Hungarian notations, it just initiate well, actually, let me use a better words like breaking my tongue. It says that whatever the type of the class or the type of the sorry, not the type of the class, the type of the variable should indicate its class. So if I'm making a hash table of an address book, I have to mention it like this: ht, let's say a hash table, and then address book like this. So this is actually a Hungarian notation, and there are really if you are searching online, there are some people asking on the forum, we are making a meeting in the company, for example, to decide if we are going to use Hungarian notation or Camel Pascal notations, let's say. They are really it's really very concerned, people really concerned about that, because you have a huge production pipeline, and people just, you are not only the one guy who's going to look into the code, there's going to be 10 to 15 other guys looking into the same code which you are doing. So you're going to have like you should comment your code using the summaries which I told you about, like, you know, putting the like double slashes like this, and you type the summary of the class or the summary of your members and all those stuff. So please take care about that, it's really important. Generally we are going to use the camel, oh excuse me, this is going to be Pascal notation. I'm going to use it for all functions and well, probably also members, and I'm going to use it just for my variables here. I'm just going to use it like normal camel notations for now. Alrighty, so let's get started. Now, what I want to do, let me by the way, right now this is private, but I would like just to put there private. Anyway, I love actually just to, you know, like define things. Public, and then void, and then add contact, and then what I'm gonna do, I'm just gonna pass their contact, let's say small letters, right? As you see here in C#, working with C# is case sensitive. Okay, now looking to contact, as you see here, I didn't pass a nickname because I'm just, when I'm trying actually to add a contact over here, just like push the class there. I mean, push the object there, and then the class will manage everything. I didn't actually need to put add contact and then just say family name, phone, first name, and so on and so forth. I just passed the object, and here everything is just going to be processed. You don't want to actually put like this string, nickname, and so on and so forth, because you have and so on, you know, like blah blah blah. So you really don't want to do that, because it's not good practice, at least in programming. It's actually, you shouldn't do that. So I just simply pass a contact object, and this really raises another question. People just could be confused. Why I just pushed the contact class? Why I didn't just push personal or professional contact? I could have two versions of adding a contact. Well, what about inheritance and polymorphism? I'm using actually the same feature here, the same feature. I'm using if I fetch any of those, it's gonna be treated exactly the same like a contact. Okay, so this is a very important, and there's a very better way. This is actually, here you go, you are using the real polymorphism in your application right now. Alright, so address book, first of all, I have to make sure that the nickname doesn't exist. So if actually that nickname, by the way, I made really a very funny mistake in the class about that nickname thing, and you're gonna see it why. I have actually to check if that nickname exists in my hash table. Now, a very important thing, very important property about the hash table, all the keys have to be different. You cannot push the same key, well, twice. Alright, you cannot have the same two keys twice. So I cannot have the same nicknames. Because once the hashing function is hashing that key, it's gonna be the same, and then you're gonna have a collision in your data structure, which we don't want to. okay, and which is also strengthen the part where you're gonna have your address book gonna have a really very organized way, so you don't have two nicknames the same. You're gonna have two different, 2, 3, 4 thousand different nicknames, all right, which is a very important thing. So I'm gonna use a very simple function here. If address book dot contains, and if you see here, before I even go to contains, there's a lot of functions over here. You have add, we have, I don't know, queryable. Right now this is link or something like that. You have clone, contains a key, contains value, copy to, count here it represents actually the number of key value pairs there, how many records are there. And as you see here, there's a lot of functions and properties which are waiting for you to explore. Now it's really nice. I'm usually, sometimes when I was beginning my first footstep inside C#, I was usually doing like this. I'm just typing making it like a hash table object like this one, address book, and then just I hit the dot and just see the functions, what they contain, how they can help me. This is a really very good feature, this autocomplete feature, and actually called the IntelliSense in Visual Studio, especially for C#. It's really great. Now as you see here, it takes an object, or polymorphism also having there also again. So object, as I said, is really the Papa class of everything, so I'm actually trying to check out if that one contact.nickname exists. Alright, if it exists, just throw to me a new exception if it does exist, because I don't want it actually to exist. And when I hit the open brackets, I can actually it's gonna throw the exception, the default exception of the Visual Studio. Alright, which you shouldn't probably do, because, well, if the user of your application gonna look to the default debugger of your Visual Studio, it's gonna be kind of scary for him, so you have to kind of make it beautiful a bit, shall we? So if I hit down, the arrow keys, by the way, the arrow down key, I have actually a string message. There you go, you can actually print your own message, and here you have kind of, I don't know, an exception thing which I'm not gonna explore there. So I'm actually kind of interested in the message, which I'm gonna say like, this nickname already exists. Let's say, there you go, exists, and a couple exclamation mark to make the guy wondering why this is happening. And then if this is actually became true, it's gonna just throw an exception and exits the function. If it is not, I'm gonna just say address book dot add, and then I'm gonna open a bracket over here. Right now I said the key is gonna be my nickname, right? So I'm gonna just say contact dot nickname. Oops, sorry, my bad. Nickname, comma, and I have to put the value. Now what's gonna be the value? Well, did you guess it yet? Contact. Okay, I just used the property of the object contact, which is passed to me from here. I just fetched it in here as a key, and I used the whole object again and just put it as a value. So it's it's okay. So right now we have the contact. Well, if I would like to remove one, sometimes you would like to make it bool, actually, if you would like to see if it's successful or not, which is kind of interesting too. I'm gonna actually keep it like that. You can also even add the contact, like make it also boolean if you want to. So it's gonna be cool, I mean, to have it. Remove contact, and of course you are removing by nickname. By the way, you could even like do like this. Let's say I'm gonna put it here for myself. I'm gonna say removes contact by nickname. But what I'm gonna pass inside the remove contact is gonna be, it gives me an error because I don't return. If I just return false, it's gonna work out. So just you know, to get rid of this red line, so I can concentrate. So I can actually here add the description, returns, sorry, true if, oops, if the contact removed successfully. Here you go. If I'm saying here, I'm gonna pass also contact object. Now I'm passing a contact object because I would like to be fully object oriented. I'm not gonna pass a property of a contact, just pass the object, deadlock class, just manage everything, alright? So this is how we're gonna work from here now on. Of course I'm gonna check first if this guy exists already. If he doesn't exist, why I will just erase him while he doesn't exist, right? It's kind of logical. So if he exists, well, hold on a second. Let me see. If he doesn't exist, isn't it? I should have actually, if he doesn't exist, if he doesn't there, if he's not there, through new exception, and I'm gonna say this contact doesn't exist. So how can I remove a contact which doesn't exist? Okay, and of course I could, well, I could actually like also there return, I'm gonna for example like return true at the end. Alright, so this actually like throws a new exception. Okay, contains is actually a Boolean function, if you didn't notice yet, a Boolean function which determines whether the system of the system the collection of the hash table contains a specific key. If it doesn't contain the key, then it just returns you false. So I'm just actually using it right here, okay, for people who didn't notice yet. Well, else just address book dot remove, as you see here, simply as that, and then I'm gonna just say pass the key, so contact dot nickname. Now for you to know, once you remove the key, return true. Alright, once you actually remove the key, you immediately remove the value, because values inside the hash table cannot exist without the keys. Okay, so you cannot have a word in your dictionary if you're having a Bosnian English or English Bosnian dictionary. If you open it up, you cannot have a meaning without a word, or a word without a meaning there. You should have the word and the meaning. If you have a word without a meaning, then this word will not be written or printed out in the dictionary, right? It's quite also logical there. Okay, and through new exception, by the way, just exits out the function immediately. So what we have here, I just added also here a description so I can show you something inside the program class. We're gonna see it. It's really nice notation. Let me see, what do we miss? So we add, we remove, we search by a nickname. Oh, that's really fun. Now if you would like to search by a nickname, so public search by, oh sorry, public, if I would like to search for a nickname, so I have actually to return a contact, right? So if I'm actually searching for well, I'm actually searching for a contact. If it found it, if it finds it, just return it to me, right? So let me see, contact search by nickname. All right, I'm just gonna pass here a contact. Alright, let me like do so. Alright, so this is the same repetitive thing, but just I'm gonna remove the, oh, I could actually, yeah, I could actually use that one. Okay, I'm just gonna check if he's there. If he's not there, he just doesn't exist. Or actually I couldn't actually knock through a new exception. I just could actually console.write line, but we're gonna see later. Probably I could just say, yeah, I'm just gonna say console.write line, just gonna notify the guy .write line this, oh sorry, I actually forgot the strings part. Or I could use actually the same exception. Well, okay, I have a better idea. Let's use the exception and I'm gonna see how the code looks like, and then if it is not good, then we're gonna actually have to, I'm gonna just change it to console.write line. Is gonna be easier. Alright, so if that guy doesn't exist, then we cannot search by it. If he exists, then I'm just gonna say address book, and there's a very nice indexing part where you can actually open a square bracket and you can just have the key. So you can say like this, return address book of the key contact.nickname. Oops, again I made a mistake. Here you go, nickname. Alright, But the problem is, what you're gonna see, I have an error over here. It just says like, why? I'm just returning a contact, isn't it? But this is actually where it goes why the generics are better, because if you are making a generic collection, this wouldn't be a problem. But the problem is right now you have a non-generic collection, so you have everything is a type of an object. So as you see here, cannot implicitly convert type of object to business.contact. So you have actually to cast it. So I'm gonna type here contact between brackets. Right now everything gonna be just fine. Alright, so right now I can actually search inside the address book by just, it's like an array, indexing an array, like just I'm giving the key, give me the value right away. So this is really very this excellent way of having a hash table, working with it, because you see it's like stunningly fast. Okay, let's say I'm gonna search by family name. Let me see first if we have an easier function to finish faster. Well, print the address book is kind of a lie. Yeah, it's okay. It's gonna be easy. Contact. I'm gonna return. Actually, hold on. Now let's have a look at this. The problem is, if I search by family name, what if, for example, I know, for example, you and your brother and your other brother, let's say, or others, whatever. So I know a couple people of your family and I have their phone numbers. Now the problem is all of you are going to have the same family name. Now I would like actually to search inside my address book, retrieve all people having the same family names. Now this is actually going to request us to do something a bit like sequential search. Of course you can even optimize it by using another hash table and link the other hash table together, mix them up, but I'm going to actually leave that for you if you would like to research even deeper. This is actually the tip. Just use another hash table for indexing other people. Just think about it a bit and then show me what you can do actually on the forums. It will be really nice to see how do you guys think about it. I'm gonna return actually a list. Okay, I'm right now trying to use generics. Here you go, list of contacts, and I'm gonna call it like search by family name. There you go, and like that. And of course I'm gonna pass a contact. That's I mean quite that's logical. Now of course when you are searching by a family name, I will not check out if this contact exists or not. What I'm gonna do is like there's of course a lot of checking that you can do, by the way, but I'm actually not gonna do those checking just to minimize time. I'm trying actually to deliver an idea here. Probably by the next for example third lesson or so, we can actually see, or we can actually even polish it out by making really perfecting it, so making errors or making the application much more friendly to the user. Okay, right now I have actually to loop over the all contacts out there. So usually you are used to for integer whatever value it is equals to whatever number it is, semicolon, and then you go further. Well, this is one way to search. There is also another way of searching, which is a very clean and nice way of working with an object-oriented programming, which is called for each. Now for each loop is quite fascinating. Let me just put on, well, not Notepad, MS Paint, let's say, just quickly, and let's look at this. Well, my professor of programming once, he explained it to me like that, or to us in the class like that. Well, if I imagine that we have an apple tree. Here you go, a very pure African example. Okay, and let me just keep the tree on. I love details. Well, I could have actually drawn the box first, but I will not, just push it. Right? Oh, cool, it works out. And if I say that I have a bunch of apples, okay, so let me try to see if I have a filled, well, it doesn't matter, if I have a bunch of apples over here, okay, I'm just trying to draw randomly. Here you go. Now if I have a bunch of apples, now for each loop works like this. You have a monkey on the ground. Alright, I know it sounds funny. You have a monkey on the ground with a bucket in his hand. And you're asking that monkey to just jump on the tree, get all your apples, and put it in the bucket. Alright? In a bit, let's go to the address book way. This is your address book, this is the tree, and your contacts are just the apples. And when you are making a for each, you're actually jumping with the monkey, just getting you the apple, putting it in the bucket, and then comes back to you. And then goes back again, get just the apple, and just, like he just, getting one apple at a time, like looping on every single one. Now, this is the basic idea of a for each loop. Now, a for each loop is a read-only loop. You cannot actually modify there. So you are actually reading the apple. So you imagine the monkey like copying the apple in his bucket and he giving it to you, but this contact is still there. So if I'm saying that the for each, if I'm saying for each contact in my address book, it means that he's gonna loop over each single one, getting a copy of it, and I look at it, or get a reference of it, I look at it. Just like this is a, probably I could not explain it in a very scientific way or not correctly way, but this is actually the nearest explanation that you can actually like easier to get without wasting a lot of time. Alright, so this is how for each loop works. Now I'm gonna just say for each, quite logically have for each, and then I'm gonna say for each contact, let's say C, in my address book. So in my address book, which part, what exactly, I'm actually having a complicated data structure. I cannot search in it like that because you have a key value pairs. It's not a single array. If you have an array, you got just say for each contact in my address book, if it was an array, but this is a hash table, you have keys and values. So I can say for each address book, for each contact in my address book dot values. Okay, so the collection of all values, okay, do the following thing. If contact dot family name dot equals, or I could actually like do like so. Okay, since it's actually a family name. C dot, sorry, family name, then just I will say, oops, I forgot to initiate a list here, sorry. So I have a list of contacts. Alright, so cont list, I'm gonna call it like that, equal to new contact list, because I have to initiate a list where I can put everything there in the bucket, right? Like I'm gonna put everything in a list and return you a list of family names, or a list of contacts with the same family name, right? Okay, so for each contact, alright, so what I wanted to do, yes, so cont list dot add a add actually that C. Alright, give me a copy of that C just right in. Okay, because of course I cannot say add contact because it's gonna be meaningless. So I'm gonna just add the same contact over and over again. So I'm gonna just say if this guy equals that guy, just put me that C here. Just make a copy of it. Just put it to me there. All right. This is actually it. Now what I'm gonna do at the end, just return that cont list. All right. As easy, as simple, and very straightforward. I mean, of course this is called a sequential search, by the way. So it means that you are searching one by one. So if you're gonna have a 1 million guys in your contacts and in your address book, and then the contact which you are searching for is in the millionth place, this is gonna be taking for you a million of iterations until you get there. Now it's quite beautiful, of course, to use other searching algorithms in order just to search like that. This is a way. Another way, as I told you before, just try to combine another hash table with that hash table in order to make it, it's gonna be a bit complicated code, but it's gonna be stunning faster than this one, okay? But I'm gonna leave it to you as just like does like a task for fun to you guys, for just to do. Okay, so let me see. We got search by nickname, we got remove contact, add contact. Let's hope that I didn't make a mistake over here. I'm gonna use the generics. Oh, print the address book. Oh, well, that's quite fun. If I would like to print the address book, I'm gonna just say public override to string, of course, right? And then what I'm gonna say here, just print me the contacts. Alright, so I'm just gonna say well, I have actually to loop over them. Sorry, I forgot about that one. So because I have to I have to loop on every contact in my address book and just list them out. So I have to make another for each loop. But first of all, I have to create a result string, because if you are returning a string, you have to return a complete whole string. So equals to, well, sorry, I'm gonna create a string result. Okay, and I'm gonna have for each contact, see in my address book dot values, just result plus equals actually c dot to string. Okay, I'm gonna just keep it simple, like c dot to string. Hold on a second, let me see. There's something wrong probably I made over here. Let me just try to add those brackets just to make it safe. Are we saved yet? Oh, I actually used the Java way. Sorry. Here you go. In actually address book. Actually, in Java you have to put the colon to string. Okay, and then at the end just return to me the result. Now, of course, polymorphism is working here again. So this is actually unassigned. Alright, let me just assign to you something like an empty string over here. So actually, like C# we've used actually to assign a result to a memory garbage. It has to be like nullified or something like that. So here you go, just like zeroed it out. So for each contact in my address book, that value is just print me that guy. Okay, and return to me at the end the result, the whole thing. Okay, this can be. Are we done? Add a contact, remove a contact, search by nickname, family name, and we have to print the whole address book. Right. Okay, so let us actually go to. I know it's kind of really begin to be very long lesson. Well, actually, as a matter of fact, I'm going to use that one. But of course, when you are using a contact, you don't use that contact. You're going to use personal or professional contact. You never actually go to the base class and create. All right. So you are using only the child classes. So that's why you created them, right? Contact equals to new professional contact. Now, if you look over here, let me see. And as you see here, I just have only a single class, which is the default class. If you didn't notice, I actually didn't have the complete class because since I actually didn't create one, right? Excuse me, complete constructor there. I'm talking about constructors. So if I say prof contact dot, I have company name plus the email and family name and everything, but I have the company name is added. That's really cool. So I can actually have a nickname. Now your application always provide a nickname and shouldn't be always the same. Let me see, like Mohammed again. Let's just try to test it for fun. And prof contact. Well, to be honest, I could actually like create this off the camera because it's gonna be really easier. Let me just to put the company name over here, like fit. It's actually not a company, but anyway, I can create an address book equal address book address equals to new address book. Okay, And as you see here, I'm just not accessing. Look here, also the encapsulation goes. I'm not actually accessing this hash table. I don't touch it at all. What I'm working with is just objects and classes. I'm not working with variables over here. I'm not, even though it's an object of a class, but this is actually like I'm not working with the member of that class. This is actually a much more cleaner way of working with or working in an object-oriented world. By the way, in C#, C# is considered to be a managed code. Managed code is mean everything is just fully object-oriented. There are pointers, because there are some people who are making mistakes. They say there's no pointers in C#. There are pointers, but they are just actually hidden from your eyes. You can actually go to unsafe code. There's something called unsafe. You're just beginning by unsafe open curly brackets, and then you begin playing with pointers and all those stuff. But of course, it's quite dangerous, and it's really not advised to work with in C#. Alright, this is a very important thing to know. Alright, so add a contact, so I can just open a bracket and just pass the object. Okay, so I have a contact object, right? That's quite easy. Address.add another contact. I'm gonna just call which one? Prof contact. Okay, and oh, probably this is it. I just say console.writeLine my address book. Thanks a lot. Let's keep it just simple, and let's see, because I really have a big doubt that this application gonna run from the first time. So start debugging. Well, here you go. Here's an exception. As you see here, I just have an exception raised immediately in the compile time. Oh, okay, I have a better idea even. Let's do it like this. Let us actually just say console.writeLine, and it's gonna be easier for us all. Console.writeLine. So that's why I actually didn't want to decide immediately. I wanted to see what's gonna happen. In Windows form, you could actually replace this like, okay, this contact doesn't exist, so I can actually like put this here and take this out, right? And I could copy the same thing and just paste it over here. Okay, cool, we have everything just fine and nice. Alright, so let's start debugging again. You see here, it's well, so that's why throwing exception is really nice. So that's why actually you have to use a try-catch block over here. Right now it's really advisable to use try-catch blocks if you want actually to do this. So right now at least I know that this current working. I'm actually gonna move in the next lesson polishing out this application again. So we're gonna polish it, so we're gonna really make it really nicely working. So I'm gonna just write there whatever it is, like hi or hi. Okay, it doesn't matter. Start debugging. Oops, let me just hit Control F5. Start without debugging. Alright, let me see. Okay, so you have a nickname. Well, I could actually just modify the address book class over here. Where is it? Result. And probably I can actually even concatenate that with a N, right? So we can have actually, instead of having the contact name or the second address book just stick there. That's what I wanted actually to escape. Well, I could actually just, well, I could make it even easier. I could just even go to the contact class, and no, actually inside the personal and professional and personal contacts, I could just add here the plus the new line. Okay, N. Okay, I could just copy that part, put it here in the personal contacts. Okay, let's start without debugging, and here you go. So we got, I even could even put two more, like Control C, or I could Control V8 again here. Could like add two new lines. This professional, personal. There you go. Let's see what's gonna happen. Here you go, it's much better. Now it's much more readable. As you see here, I could actually print everything out in my address book, which was really great. Okay, so this is cool. Can we remove something? Okay, so let me just close everything which I don't need because it confuses me a lot. I actually middle click every that, all that. Now if I say I could, after that, just to make life a lot easier, I will not actually print everything. I will just say, well, yeah, I could print everything. I'm just gonna say address dot remove contact. I'm gonna just pass the contact, so I'll remove myself from there. You see how it's beautiful working with objects. Just send the object and just forget about everything. You know, that's the coolest part about it. And then you're gonna say console dot write line, and I could have actually just copy pasted the whole thing out there, but let's see what's gonna happen. Start without debugging. Oh, it worked. Here you go. It just printed out. If I just say, I usually don't trust myself when I write applications that it's used from the first time. It's kind of weird to me. All right, so if I just put a break over here and just like start without debugging, here you go. So it's actually printed only a single one. So it's really removed the object. Now let us try to search by the same family name. And if I say have a contact dot family name, and if I say equals to Elzayed, for instance, if I add here in the professional contact prof contact dot family name again, is gonna be, for now, just quickly. Okay, I could even control this to upper or to lower. I'm telling you, we're gonna have really to polish this application later on. We're gonna really make it very beautiful in the next lesson. I could have added even one more contact to add it out there just to make something different. Probably I'm gonna make a personal contact one, and it's gonna be let's say cont for now, equals to new personal contact, and it's gonna be cont dot nickname equals to hello, whatever it is, doesn't matter. And where's the semicolon? Here you go. Cont dot phone, let's say something gonna be like whatever, oops, sorry about that people, here you go again, whatever numbers I would like. And then cont dot family name is gonna equal to, what happens with that long, whatever. Okay, so we have something like that. Of course, I do not forget to add it to the add contact part, so I'm gonna add cont, and let's just let us just search by family name. So I'm gonna just say address dot search. Let's search first by nickname. So I'm gonna search for cont, and let's see if he retrieves it to me. And of course nickname is actually returning that, so I'm gonna just say console dot write line there. And of course it's quite logical, and you know why? Because search by contact name returns to me a contact object, which I already overloaded to string, so it's gonna be printed immediately right away. So I'm gonna just type there like something additional in a really high caps, contact found, and then once I finish with that, we're gonna have also address dot search by family name, and then we're gonna have by family name I'm gonna just pass cont again, since it's already I have already this list. Let me see. So cont, oh sorry, prof cont, sorry, or contact, it doesn't matter anymore, just I'm trying to search by family name, so I'm gonna get that and that one. And it's of course gonna be returning for me a list, so I can actually even like compact this code, like for each contact C in that guy. Since it already returns to me a list, I mean it's like logical, I'm just gonna return a list, so I'm searching in every item in that list there. I'm just gonna tell him C console dot write line, and then print me just that C. And let's get what gonna happen. I'm just gonna say here like console.writeLine. I believe, guys, I'm not explaining everything here because I believe it's quite logical, whatever I'm doing right now. Search by family name. Okay, I'm gonna just like make a huge split over here and a huge split over there so everybody can see that. Let's hope that's gonna work. I hope so. Oh, it worked. Oh, it's not. Well, it retrieved me only one, which is kind of interesting. Probably I mistyped someone. So contact found. At least I already found a contact. Here you go, nickname and everything. So I could actually search there. I have already, look, I have already added 3 contacts, removed one and one. Oh yeah, it's quite logical. I already removed myself. Oh boy, that's really. Oh man, sorry about that. Okay, let me try to just comment that for a while and just start without debugging. And here you go. Of course, I'm gonna retrieve both of them. It's just kind of oh my, sorry about that. So I have actually all of my contacts. I have printed again because I was actually trying to remove one, but since I removed my contact right now, it's quite logical that I didn't have it in the previous time. Right now, when I commented that line, I stopped removing my contact. Right now it retrieves me both contacts with the same family name. Alright people, I know it's quite it was really long lesson, but I hope it was really fruitful. Just if you didn't get any point, just watch the videos again. If you really still didn't get it, go to the forums, scream out, just tell me I didn't understand, and then I'm gonna actually trying to help you out if you're on the faculty, or help you out through the forum. Just feel free to ask any questions. I'm on the forums every day. Alright, the next lesson we're gonna actually polish out this application to make it really working. So we're gonna have to manage user errors and all those stuff, and then I'm gonna leave you guys the task of making out the menu and inputs and all those stuff. So I'm just gonna make a testing out application, making sure everything working, and we're gonna polish it out together to make it really nice and neat application which you can actually use later on. But the part where the menu goes, user inputs and all those stuff, I would really like you to make it on your own, and it's really nice to begin from now actually working on that. And I'm waiting for your I actually tried to hit Control S, sorry about that, and I'm really sorry, Control Z, and I really would like to see your contributions over the forums. Thanks a lot for listening, guys. See you in the next lessons.